right. Good evening. How are you? How are you? Hope you're fine. John. Hope you're good. All right, so let's get into it. So we'll be discussing scalar and vector quantity. So, hey, sorry. After exam, you will be able to rest. Sorry, it's not easy. After exam, you'll be able to rest. So can we go on now? If you are just give the video a thumbs up, like the video. Can we continue? Okay. Now, we've already talked about, from physical quantity, just a quick revision. Physical quantity, where we talk about any quantity that can be measured is said to be physical quantity. Any quantity that can be measured is said to be physical quantity. Any quantity that can be measured, any quantity that can be measured is said to be a physical quantity. To be a physical quantity. So now, it's said to be a physical quantity. There are different things that you have to understand when we talk about physical. There are two types. The derived quantity and fundamental quantity. So for the fundamental quantity, we are talking about 7 of them, right? When we talk about the length being a fundamental quantity, the mass being a fundamental quantity, right? The time being a fundamental quantity, temperature being a fundamental quantity, right? The amount of mole or amount of substance being a fundamental quantity. 1, 2, 3, 4, 5. Also, there's something called luminous intensity being a fundamental quantity. Understand? The length is a fundamental quantity. Mass. What does a fundamental quantity mean? A fundamental quantity means any quantity that, I think I'm coming. Sorry. Any quantity that it is independent is what they mean by fundamental quantity. Any quantity that is independent is what they mean by fundamental quantity. Any quantity that is independent is what we talk about when we talk about fundamental quantity. Okay. So now the length. Now what is the unit? The unit of length is meter. The unit of mass is kilogram. The unit of time is second. The SI, now these units are not just anyhow, they are SI units. Okay, they are SI units. That is generally acceptable. Those are the units. Time can be in hour, time can be in year, time can be in time. That time can be in years, months, weeks, that's time. But the SI unit of time is second. Temperature can be in any unit, but the SI unit of temperature is what? Is Kelvin. You understand? the amount of substance, the SI unit is what? Is mole. Now, luminous intensity, the SI unit is candela. Candela, CD. Candela, that's the SI unit. Now, what we are trying to say is that this unit, this quantity, they are independent. This quantity are independent. You understand? But derived quantity are dependent. Just like the name. They depend on fundamental quantity. Derived quantity depend on fundamental quantity. And just like you can see, they are what? They are endless. They are endless. That is, you cannot exhaust them. So far, you can join two quantities together, they will always form a derived quantity. For instance, velocity, which is displacement over time. You can see now that this velocity here depends on displacement, which is a form of length, abi, then time, which is a fundamental quantity. So this is a fundamental quantity, another fundamental quantity, to give a what? A derived quantity. So you can, once you can have two or more fundamental quantity, you can always have a what? A derived quantity. Okay, so this is second and this is in meter. So the unit of velocity here will be what? Meter per second. So now for dimension, you must understand this. Dimension, you know, it is, we say length is L, time is T, and mass is M. So we just use the letter that begins it, that starts it. So if I say find the dimension of velocity, now since velocity is displacement over time, now, and I said this is a form of length, abi, so I can say this is L and this is what? Over time, T, because this is what is the dimension, no, not the unit. This is the unit. Meter per second is the unit. You understand? Meter per second is the unit, but this is the dimension. This is the dimension. Go. Sorry. Okay. Trying to adjust. All right, so that means this is L per time. That's the dimension. So we can always find dimension of anything. For instance, if it is acceleration, since we know acceleration is what? Velocity over time. And I already got the dimension for velocity here. So I'll just use it. This will be L per time all over this time here, which is T. So it will now be L per time per time. So it will now be L T. This is 2T minus 1 minus 1. So it will now be LT minus 2. So this is the dimension for what? Acceleration. Acceleration. So that is that. So are we good? John, do you get this? John, do you get this? Do you get this? John. John, do you get this? Okay. All right, so let's go. So let's move into scalar quantity. Scalar quantity. Scalar quantity and vector quantity. Now, when we talk about scalar quantity, these are quantity with only magnitude. Now, when I mean magnitude, magnitude just means size. They are quantity with only magnitude. While vector quantity are quantity with both magnitude and direction. They have both magnitude and direction. Understand? So now let's delve into the examples. Now, for scalar quantity, we have number one, time is a scalar quantity. It just have magnitude. Length is a scalar quantity. Mass is a scalar quantity. Pressure is a scalar quantity. Power is a scalar quantity. Work, exactly, good. Speed, in fact, you should not miss this one because it is S. Another very important one is what? Distance is a scalar quantity. You understand? It's a scalar quantity, so you should not miss them. You should not miss them at all. Exactly, distance is a scalar quantity. What other example do you know? What other example aside from the one I've listed? So temperature, exactly, is a scalar quantity. It does not have direction. Temperature. There are a lot, etc. So you should know the unit. What's the unit of time? Second. The unit of length? Meter. Volume, exactly. Area. In fact, area. Height. They are so, they are endless. Volume, yes, they are all scalar quantity. Energy, yes. Work, power, energy. You can go on and on. They are all scalar quantity. They don't have direction. They only have magnitude. So let's start. What's the unit of time? Second. The unit of length? Meter. Now, when I mean unit, I mean SI unit. So they can give you the unit of length to be, let's say, kilometer. It can be anything, but the SI unit is meter. This is mass. For physics, the SI unit is kilogram. Pressure. You know that pressure is what? Is force over area. So, and the unit of force is Newton. The unit of area is meter square. That's Newton per meter square. Newton per meter square. So power is what? Watts. That's the unit. Work is joules. Speed is meter per second. Distance is meter too. Energy is joule. Temperature, SI unit is Kelvin. Don't forget the other unit of Kelvin. The other unit of temperature like Kelvin, Celsius, Fahrenheit, Reaumur. There are a lot of units like that. Area, meter squared. That's the unit. Height is the form of length, meter. Volume is area times height. And that's why this one is what? Meter cube. Okay, now let's go to the other one, which is what? Vector quantity. For vector quantity, we already said it has both magnitude and direction. Okay, now let's go. Examples. What are the examples? The number one thing you want to talk about is what? Displacement. Displacement. Another thing you want to talk about is what? Velocity. Right? Another thing you want to talk about is what? Force. Right? Another thing you want to talk about is what? Is movement. Movement of a force. Right? They have another thing you want to talk about is torque. Right? What other quantity do you know that is a vector quantity? That has both direction. Momentum. Momentum. What other one do you know? What other one do you know? Impulse. These ones, they have both magnitude and direction. Yeah, what other one? Impulse. What other one? I'm listening. What other one do you know? Can you remember? Yeah, list them. John, can you see? These are examples. What other vector quantity do you know? Yeah. Aside from displacement, velocity, force, acceleration. Acceleration, yes. Acceleration. What other one? Acceleration. They are all vector quantity. This one, displacement, velocity. We'll talk about their units. I'm listening. We talk about force, we talk about velocity, electric field, yes. In fact, let me write all fields, not only electric field, all fields, they are all vector quantity. 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 All fields, exactly, gravitational field, yes. So we already, don't forget, we have listed, what's it called? We've listed, okay, we talk temperature gradient, yes. Don't forget fundamental quantity, we listed them. Length, mass, time, temperature. I'm just trying to, temperature, amount of substance, abi, which is in mole. Luminous intensity, which is in candela. There's another one, current, which is ampere, abi. Yes, angular velocity, fantastic. We have another one called the magnetic flux. Magnetic flux, which is also a fundamental. The unit is Weber, so that you will know that. Angular velocity, yes, very correct. So we can go on and on to talk about, these things that are, that are vector, right? Can go on and on to talk about them. So but then we don't have the whole time, so let's just move on, okay? So but if you can know all these things that we've mentioned, at least you should be able to answer questions on which of this is a fundamental quantity, derived quantity, which of the following is an example of scalar quantity or vector quantity. You understand? You should be able to know all of those things. Do you understand? So let's move on. So the next thing we'll be going into now is what we call motion. So this is chemistry for beginners. Sorry, physics for beginners. So we're talking about motion. We're talking about what? Motion. That's the next topic. We'll be talking about motion. So that's what they will ask you under this one. Weight, yes. Weight too. Weight too. Because of the acceleration. You know, weight is mg, abi. This g is the acceleration. And also you should know, I think this one is important. The difference between weight and mass. Please take note of this. Just know that mass is constant while weight varies, right? Because weight is W equals to mg, right? Yes, mg. And mass is just m. So anywhere you go, mass is constant. But weight varies because the earth is not a perfect sphere. The earth is circumnavigation in shape. That there's also circumnavigation of the earth. So the earth is geoid. So if you have the center of the earth and you draw a radius, can you see? This radius is bigger than this radius. This is small r. So if you are here, you see that the radius here is longer. Look at the radius here is smaller. So if you are here, you experience different weight to someone that is here. Do you understand? Like someone that is here and someone that is here. You understand? So the earth is not a perfect sphere. So that is why weight varies. Okay, note that. Do you understand? That's why we now define matter as anything that has mass and occupies space, because weight can be zero. Weight can be zero. So when W equals to mg, when g is zero, weight will be zero. So we have left that definition. So now let's go. Motion. Motion. The word motion in simple terms just mean movement. Just mean movement. So motion is typically described in terms of velocity, acceleration, displacement, and time. We'll be talking about something like velocity, acceleration, displacement, and time. These are the things we'll be using. You'll be familiar with it. You understand? Thanks for the likes, for the love. Yeah, these are the things you'll be seeing. So velocity, acceleration, displacement, and time. So these are the things you'll be seeing. So now, for instance, you have to understand that an object's velocity cannot change unless it is acted upon, right, by a force. And that is what Newton is trying to say, that you will only be, that's why I used to say it, if you want to sleep, you will continue to sleep. And if you are running, you want to continue running unless it is something is being acted upon, like something acts on you, right? So that is what you have to understand. So if you want, so for example, one can walk about, you understand, one can walk, one can be sleeping, but you always want to either change the sleeping position, or you want to move, or you want to stand up, unless something acts on you. You understand? So motion typically is defined as the change in position of an object with time. Change the position of an object with time. That's what we define motion as. You understand? Change the position of an object in time. So you also understand that there's this man that have studied motion. Different people have studied motion. You understand? Just for you to give you a perspective. You understand? Its property because of its importance. You understand? People have studied it. You understand? Because of, we move, right? But there's an Italian man, actually. They call him Galileo Galilei. Galileo Galilei. You understand? Galileo Galilei. So this man was the first man to systematically study motion. You understand? Was the first man to systematically study motion. You understand? But this guy, Newton was the first person to work on motion. So his work was still noted. That's why you see some laws like Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. Okay, so now let's just leave that and go into the types of motion. Types of motion. There are different types of motion. In the first one, we can talk about random motion. We can talk about linear motion, right? We can talk about oscillatory motion. We can talk about vibration. We can talk about rotational. Now this oscillatory, some people call it vibrational motion. Rotational motion. Okay, in fact, there's another one we can talk about. Relative. When you are moving in a car, you would have experienced this, abi? Relative motion. We can talk about relative motion. You understand? There are different types. We can even talk about circular motion. Okay, circular motion. But let's just stay with this and discuss it. Now, for the random motion, this is a type of motion in which the body moves in a what? In a non-linear format. You understand? In a non-linear format, the body is just moving randomly. You understand? Let's start from the random motion. Random. The body is just moving randomly. For instance, let's say you have one body move like this, like this, like this. Can you see? It's moving in a non-linear form. In a what? Non-linear form. Can you see? It's just random. It's random. Give me a minute, please. A minute. In a non-linear form. It's just random. In a non-linear form, abi? How can you tell me an example? You can tell me an example when gases move. When gases move, right? That's a very typical example of a non-linear motion, which is random. Another very good example is, let's say you split something into the air. You pour something into the air. That's another very fantastic example. You understand? Or when birds are flying in the air. That's another. Can you start again? My network was not good. From where? Oh my God. From where? Is it from motion or what? Is it from motion? Where? Which place? John? From where, John? From where? Types of motion. Okay. Yeah, that's where we are. Okay, what are the types of motion? Random motion, linear motion, oscillatory motion, rotational motion. In fact, I have to tell you that there's also circular motion, right? There's circular motion. When we talk about simple harmonic motion, then there's what? Relative motion. Have you gotten that? Relative motion. Then we start from random motion. Explaining random motion now. Are you okay now? Are you okay with the explanation? With the types of motion? I've not even explained. Are you okay with that? Okay, good. So let's go to random motion. For random motion, just like I said random motion, when you throw maybe a bird flying in the air, is random. If you just put something, throw something to the air, is random. So, and I use this to molecules of gas, molecules, of gas, they move in a random motion. If you have seen it, if you are boiling water, for instance, the water vapor, you just see that it's moving randomly. In fact, that's the first assumption of kinetic theory. It states gas move in a straight line, but that straight line itself, it is in a random motion. Can you see? Random motion. So that's that. So do you understand that? Yeah, thank you. So now let's continue. The second one we want to talk about is linear motion. Linear motion. Now for linear motion, just like the name implies, is the motion on a what? On a straight line. Motion on a straight line. Now some people don't call it linear, they call it translational motion. So for instance, let's say you translated from point A to point B. So you move from point A to point B. So they call it translational motion. AJ, thank you. Translational motion. Can you see? Linear. So it is moving from a fixed point A to point B. It must be fixed point A to a fixed point B. So it can be linear in that manner. Can you see? Linear. Just linear. Do you understand? So that explains that movement of a car from a point to another is an example. The movement of a man on a straight line is another example. Understand? So let's go. Another very good example is number 3, which is rotational motion. Now look at it. The way I used to explain this is that we can have a fan. This is center, fan. So that means there is a center. These are the blades of a fan, right? These are the blades. Then there is a center. So if you move along an axis, you understand? This is the movement of a body in a rotational manner about its axis, right? Now there is a question Jamb used to ask. What is the movement? What is the motion experienced by an electric fan? It's 2 types. It is both rotational and circular. Also, the earth can do 2 things. It's either the earth rotates along its axis. The earth can rotate along its axis, or it can revolve around the sun. Do you understand? So there are 2 things. The earth is revolving and the earth is rotating along its axis. So that's the principle of day and night. So when the other side of the earth shifts, there will be light, and when the other side shifts, there will be day. Like night and day. Do you understand? So the movement along its axis is a rotational motion. When the earth now move, when the whole earth move, this is earth. When the whole earth move, you understand, that's revolution. and it is the revolution of the earth that leads to a year, but the rotation of the earth along its axis leads to day and night. Do you all get that principle? Do you get that? John, do you get that? John, do you get that? Okay. I said earth can do two things. This is the earth, for instance. Okay, earth can do two things. This is earth. Okay, let me just start it here. We have sun. We have earth, Abi. This is earth. And this is sun, which is so big. The earth can rotate along its axis. Now, when this happens, can rotate along its axis. When this, because rotation along the axis, this is the axis. Rotation along the axis is what causes, so it's a rotation, that's a rotational motion. Rotational motion along its axis. So it is this rotation that causes day and night. It is this rotation that causes day and night. Good evening, yeah, good evening. So, but when this earth moves around this sun, it's called revolution. That means they say the earth revolves around the sun. So it is this revolution of the earth around the sun that leads to a year. Like they say, oh, 365 days, right? So it will take the earth, look at it. If you do geography, you would have understood all these things. But let me just explain, break it down. It will take 365 days for earth to revolve around the sun. That's what leads to a year. It leads to a year. It leads to a year. Yeah, thank you, Samuel Timmy. Yeah, I'll keep doing that. So stay tuned. You guys should like, if you are here, like, comment, and all of that. Now, but if the earth rotates along this axis, it will take what? It will take 24 hours. Abi, that's what leads to what? Day and night. That's what leads to day and night. So do you get? So there are two things I'm trying to explain. Rotation and revolution. So right, which one leads to day and night? Which one leads to day and night, and which one leads to rotation, day and night, revolution, a year? Fantastic. Rotation leads to day and night, right? Good. Exactly. That's good. So rotation, revolution, a year. Good. You have learned something like that. Rotation. John, which one leads to day and night? I've not seen John reply. John. John, which one leads to day and night? Which one leads to a year? So I didn't see it now. Say it again. I want to hear. I want to hear you. I can't hear you. Is it my network? Which one leads to day and night? I want to make sure everybody's following. Which one leads to day and night? Okay, let's move. I'll be waiting for a reply. Okay, now there are very important things that we want to talk about is equations of motion, motion under gravity. Now let's go. There are basically 4 equations of motion. Now the first one, I don't need to be telling you how to derive, but let me just, few of them I'll just tell you because you don't need derive. Is that acceleration is equal to the change in velocity over time. Now since acceleration, so acceleration equals to v minus u, like change in velocity means, this means final velocity, this means initial velocity. Now all over what? Time taken. I want to tell you how they derive the first equation of motion. So from here I can say a, this is t, a multiplied by t equals to v minus u, right? Now since we can say v, if this u come to this side, it will be what? U plus at. So that's how they got the first equation of motion. That's how they got the first equation of motion. So they can give you final velocity, initial velocity, and give you acceleration, and that's to calculate time. So this is the equation 1. Do we get that? Do we get that? Do we get that? Wow. Okay, we want to talk about the 4 equations of motion. The number 1 is, this is acceleration, which is equals to change in velocity over time. Change in velocity over what? Over time. So, and I said the change in velocity means final velocity v minus u all over t. So, and I wrote v minus u all over t. Now, if I cross multiply, since this is t, that means a times t, at, equals to v minus u. If I need v, then minus u can go to this side and become u plus at. Do you get that now? Do you get that? Okay, so now this is the first equation. This is the first equation. Number 2, I will not derive those ones. Just know that S equals to ut plus half at squared. This is distance, this is initial velocity, this is time, this is acceleration, and this is t squared. Equation 2. Now, equation 3 is, sorry, this should not be 2, this should be 3. This should be 2. Equation 2 is v squared. You can write anything anyhow, but I just want it to be, because I started with v, so I want to write everything about v. V squared equals to u squared plus 2as. Same thing, a is acceleration, distance, initial velocity, final velocity. This will now be equation 2. This is equation 3. Now the last one is S equals to U plus V all over 2 multiplied by T. Multiplied by T. It is multiplication. It's just like saying S equals to average velocity multiplied by T. Like that's, this is velocity. So it's like saying distance equals to, there's one formula like distance equals to average velocity multiplied by time. So that's what it is. But this is what they use here. U plus V all over 2 multiplied by T. Are we good? So this is the fourth equation of motion. Do you get this? Do you get this? Do you get this? No. Do you get this? Let me reduce that thing. Good. Now, that's equation of motion. Now, there is another concept that is very, very important. Another very important concept that is very, very, very important is motion under gravity. You need to understand this. I will tell you. Now, if you throw a body, this is a body B. If you throw it up, if you throw this body up, you throw it up. Don't forget, we are all on Earth. Let's say this is the Earth. This is where all of us are. Do you agree with me? This is where John is. This is where Uche is. This is where the chemistry tutor is. That's my name. We are all on Earth. This is the Earth itself. We are all on. So this is the center of the Earth. So that means you are expected that there's something called acceleration due to gravity. Now, that is why it is easy for you to jump down than to jump up. If you throw yourself up like this, you are going against the gravity. This is the center. There's a force that attracts us to the center of the Earth. There's a force that attracts us to the center of the Earth. So if you try to go up, you understand? If you try to go up, you are going against the gravity. So if you are going against this gravity that attaches us to the Earth, your G will be negative. Very important too. Your G will be what? Will be negative. Your G will be negative. But if you fall down, if you throw something down, if let's say body B, this is you throw it up, maybe it is thrown down, that means you are supporting the Earth, because this is where the Earth is. This is the center of the Earth. This is the Earth. That means you are supporting the Earth. So if you throw it down, you are supporting the Earth. So because you are supporting the Earth, your G will be what? Positive. Do we get that? You will now see how the formula will change now. Do we get this? Do we get this? Do we get this? Motion under gravity. Motion under gravity. We throw a body up, because you are going against gravity, G will be negative. If you throw it down, because you are supporting gravity, G will be positive. That's why this is this. Very important concept. Okay, good. Very important concept. Very important concept. Okay, good. That means, we said some formula that time. V equals to what? U plus AT. That means this one can be changed for motion under gravity now. Motion under gravity. That means we can change this guy to what? V equals to U plus or minus. Now, GT. Why is it plus or minus? Depending on either you throw it up or you throw it down. So it's either for upward, up or down. So we already established that if it is up, G will be what? Negative. If it is coming down, G will be what? Positive. That's what we established. Right? Now, that's the first equation. Can you see we've changed the first equation motion to G? Because if it's motion under gravity, that's why they call that G. It can be, this G now means acceleration due to gravity. So it's a special form of acceleration that is due to gravity. It's a special form of acceleration that is due to gravity. Now, number 2 equation that we want to change. V square, which is equal to U square plus 2AS. We can change this guy to what? V square equals to U square plus or minus 2GS, depending if it is either up or down. So if it is up, we already established G will be what? Negative. If it is down, G will be what? Positive. So depending on which one. So this one is positive, so that's why it is plus or minus. Now the third equation and the last for motion under gravity is that S equals to UT plus or minus half GT squared. We already start, same thing applies. If it is up, G will be negative. If it is down, G will be what? Positive. Now, why is this the last? Don't forget, the last one, it is not applicable. That S equals to U plus V over 2 times T. Times T. Now, why? Do you see G here? There is no G. So that's why it is not applicable for motion under gravity. It is only the first 3. 1, 2, 3 that is applicable for motion under gravity. Do you get that? Do you get that? Do you get that? Okay, you got that already. That's nice. Good, 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 good. So now we can continue from here. I want to also teach you something like the graph, because this is one thing that people don't know, is the graph. Okay, that's one thing that people don't tend to know. Do you understand? Is the graph. So you must know graph. So we can have what we call displacements. What we call displacement time graph. We have distance time graph. We can have velocity time graph. In fact, we can have acceleration time graph. You know, displacement over time is acceleration. Sorry, displacement over time is velocity. Velocity over time is acceleration. Acceleration over time is what? Is check. But for your level, they will not ask you all those ones. So you understand? They will not ask you all those ones. So they will just stick to what they can ask you. So you understand? We'll just stick to what they can ask you. So now let's talk. Let's do something. You understand it? It's very easy. Now for this distance time graph, which we are going to be starting from. You understand? So we can have this. Look at it. Look at it. We have a graph. This is the time in seconds. This distance in meter. Right? Now, if it is a uniform motion, so that it's starting from 0 and is building up uniformly. Can you see? For a uniform motion, it's building up uniformly like this. You know, it's building up uniformly. Right? That means you will have a straight line. Abi? So this is what we call for uniform motion, because it's built up uniformly. So we can have the area or the slope of this graph. How we get the slope? You know, if you remember your mathematics, you draw a big triangle. So the slope, or what we call gradient, of a distance time graph, this is a question in Jamb, is what? It's like saying distance, because by the time you pick 2 points, you pick this, you know, you now trace it down. You pick T, let's say this is T1 and T2, then you trace this to this side. This is what? Distance 2, distance 1. So for the displacement, or for the gradient, you know, when we always do in secondary school, slope will now be what? D2, distance 2 minus distance 1 over T2 minus T1. Now don't forget that this thing looks like something, distance over time, which is what? Speed. So the slope of a distance time graph is what? Speed. Is what? Your comment is what? What is the slope of a distance time graph? What is the slope of a distance time graph? I'm checking the comment. What is the slope of a distance time graph? Speed, yes. What is the slope of a distance time graph or gradient? Speed. What is the slope of a distance time graph? Speed. Good. Now, the second graph. Now, don't forget that this graph can also be what? Non-uniform. Can also be I will tell you how it will be. Look at this. Can you see it is non-uniform? This is distance in meter. This is time in seconds. If it is non-uniform, you will just pick a point and find the slope around that point. You will just pick a point A and find a slope. So that's the way to find the slope. It does not still change that the slope is still speed for a what? A distance against time graph. The slope is still speed. But it's just that how do you find the slope is that you find a point and you draw your triangle along that point. So do you all get that? Do you get that? Do you get this? For a non-uniform motion. Good. For a non-uniform motion. Good. Alright, so let's move on to the next one. Let's say we have displacement time graph. Displacement time graph is, we have something like this. This is displacement in meter. This is time in meter. So when if it is uniform, we have something like this. So we can also plot and get our what? Our slope. So it's like 2 points. This point, this point. So it will be T1 and T2. So if you trace this one to the displacement axis, you find your D2. If you trace this to the displacement axis, you find your D1. But don't forget, it's like saying the slope is D2, which is displacement here, over D1 all over T2 minus T1. Don't forget the D here is displacement, and here is what? Is time. So in this case now, this will be what? Displacement over time. So now displacement over time, that means the slope of a displacement time graph. What do you think? Who can guess what is the slope of a displacement time graph? What is the slope of a displacement time graph? What is the slope of a displacement time graph? What is the slope? What is the slope? What is the slope? What is the slope of a displacement time graph? So displacement time graph, the slope is y-axis over x-axis, which is displacement over time. So how is displacement over time equals to displacement? So what is the slope of a displacement time graph? What is the slope of a displacement time graph? I'm waiting. Oh. So is displacement over time speed? Okay, you said the slope of a distance. You said the slope of a distance time graph is speed. Where do you say this is it? You said the slope of a distance, this distance over time. You said it is speed. So why is displacement over time speed? I'm waiting. Oh. Velocity, fantastic. Velocity, yes, that's the answer. Velocity. Velocity, exactly. Velocity, yes. Because the quantity that is displacement over time itself is velocity. So that's the slope of a displacement time graph. Good. Now what is the third one? When we now pick velocity. So we are talking about velocity time graph. That means what is on this axis here, what's on this axis here, which is the velocity in meter per seconds, right? Then this one will be what? In time, and the time here will be second, right? So from here, there are statements you have to understand for velocity. You understand? You see something like constant, the body moves in a constant velocity. There are statements you have to understand. I don't just want to draw. The statement like constant, the body is moving with a constant velocity, because there are statements that your examiner will test you. The body starts from rest. I will explain all these things. You have to understand all these things to be able to be good. Now let's say the body is moving at a constant velocity. What does constant velocity? You know, this is the velocity axis. So if the body is moving with a constant, the third one, retardation. Retardation. Another name for retardation is what? Deceleration. The body is coming down. So these are the three terms, like three ways you have to understand this thing. So let's first represent. Number one, constant velocity. So look at what will happen. You know, this is the velocity, and when they say something is constant, it means it is constant truly. Let's say the velocity is starting with 20. Let me label this to be 20 meter per second. So when they say the body moves at a constant velocity of 20 meters, it means it is going like this. It's not even this. This is what it means to be constant. So let's say after the body will now move, it now decelerates. You see that the axis will now come down like this. Can you see? So this showed that the body decelerated, and this showed the body is moving at a constant velocity. Do you get that? Do you get that? Good. Do you get that, John? So constant velocity. Oh my God. Give me some minute. Give me some minute. We are back. I already have my backup. Yeah, sorry, we are back. Yeah, we are back. I have backup for the stuff. So, are we good now? We are back. Yes, we are back. Are we good to go? Okay, good. So, okay, the next one we want to talk about, okay, we even talk about body starting from rest. Let's do when the body is starting from rest. Let's say we have this. Right? Now, don't forget, this is velocity, as we said. I will teach you something now. And this is time, as we said, in seconds. So, now, if the body is starting from rest, body starts from rest. That statement is a statement you should not joke with in physics. When the body starts from rest, it means the U, which is initial velocity. Initial velocity. It is what? It is 0 meter per second. You must not joke with it when the body starts from rest. when the body starts from rest. You must not joke. What do I mean when the body starts from the initial velocity is what? What's the initial velocity when the body starts from rest? When the body starts from where? What's the velocity? What's the initial velocity when the body starts from rest? 0. Good. 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 So that's it. 0, yeah. So now let's see. We know that this axis, if you know mathematics very well, this axis here, it is the 0, 0, abi? That means if the body is starting from rest, that means the body is starting like this. This, because this is 0. Can you see? So the body must start like this. Then they will now say it gets to a velocity of, let's say, 20 meter per second. So that's why it got here. Then look at it. Then let's say the body now say, the body moves a constant velocity of 20 meter per second. Can you see? This constant velocity. We establish this fact. Constant velocity. Then the body now decelerated. This deceleration. Deceleration. So these are the things you'll be seeing in your textbook. So this axis A, let's label A, B, C. A is what? A body that moves from rest. That's what A means. And that body moves from rest. Then it got to a velocity V. Then that B now shows that that body is moving at a constant velocity. Then C is showing that the body decelerated. So those are the terms you should know. 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 Now let's do things, in perspective or something. Let's put things in perspective. Let's put things in what? In perspective. Let's put things in perspective. Okay, now I want to teach you something. I'll just solve one question and you see. You will see something now. Okay, let's say I want to write something and okay, you guys are we fast. Do you all understand up to this point? Do you all understand up to this point? Do you understand up to this point? Okay. Yes, good. So let's solve a question. So that we use one question I will use this question to explain everything on it. Let's say I want to put it in perspective. Let's say we have something like this. Please pay attention to this question. And we have, let's say, you are the one that will be answering. Let's say we have 5 here. And the body moves from this and got to 15. This is velocity in meter per seconds. This is time in seconds. So the body moves like this, then like this. Okay, this is the way the body moves. That means this is 5, this is 10, then this is 15. All of them in seconds, right? So that means I have 3 tables. 3, but 1, 2, 3. Sorry, let me show you. So now let's solve. We want to solve about 4 questions. If you can solve the 4 questions, you are good to go. A, calculate A, the acceleration. B, calculate the total distance. I've not explained this, but I will tell you now. Total distance. C, calculate the retardation. You see the retardation, and when something is retarding, it will be negative. Then the last one, calculate the average speed. Average speed. This is a lot of questions. If you can solve this, I'm confident that you can solve any question under this thing. I'm confident that you can solve any question under this thing. Now let's go. The first thing is, when you study this table, what did you observe? What did you observe? Some things are given. What are they? U, initial what? Initial velocity. Who can tell me what the initial velocity is from this table? What is the initial velocity? What is the initial velocity? Who can tell me? What is the initial velocity? I'm waiting. Only one person. What is the initial velocity? I'm waiting. Keep dropping the initial velocity. Hey. What is the initial velocity? Okay, 2 people said 5. 5. Yes, I agree. It is 5 meter per second. But you did not say the unit. So it is 5. It is not 5. It's 5 meter per second. Understand? It's 5 meter per second. Now, how? Because look at it. The body moves from here and accelerated. The body moved from 5 and accelerated to this point. That means there's a final velocity. So what is the final velocity? V. Final velocity. Yes, that's good. That's good. So what is the final velocity? V. But yeah, what is the final velocity? V. If you can solve this question, you can solve any question under this thing. I'm so confident. What is the final velocity? V. What is the final velocity? V. You know, you already said initial is, that means this body is not starting from 0, because this is 0 axis. If that body was starting from rest, it would have been like this, but it is starting from 5, so that's why it is 5. Then it moves accelerated to a particular velocity V, and that V, the final velocity V, is what? 15 meter per second. Now 15 meter per second. Now that means what? Who can tell me what time does it take for it to accelerate? What is the time taking? What is the time taking for it to accelerate? No, Monday, Daniel, the final velocity is not 0. This is where it started from here, 5. Then it accelerated. Can you see? to 15. Can you see? To 15. So the final velocity v is 15 meter per second. The initial velocity u is 5 meter per second. Please take note of that. So what is the time it took for this guy from here to this place? Now, if you what is the time? What is the time? What is the time? Who can tell me what is the time? What is 8 and 10? Where do you see 8 and 10? What is the time? What is the time? What's the time it takes for this guy to move from here to here? It's even here. You have to trace it down. So can you see the time taken is what? Is 5 seconds. Yes. No, it's not 15 seconds. So look at it. This guy moved from here to this place. Right? And when you trace it down, it's 5. It's not the whole time we are looking for. 15 seconds is the total time. I agree. But that is not the time it takes this body to move from here to this place. The time it takes this body to move from here to this place is when you trace it like this and come here. I see. It is what? 5 seconds. 15 seconds is the total time. This is 15 seconds from 0 to 15. That's the total time for the whole journey. Now, 5 seconds. Now, don't forget, we said one formula. A is v minus u over t. So from here we can get our acceleration. Final velocity is what? 15. Initial velocity is what? 5. What is the time? 5. From here we can say 10 over 5, which is what? 2 meter per second square. So we've answered question 1. This is question 1. Do we all get it? That's question 1. Now, some people might be wondering, why am I using, yes, it's 2. That's the answer. Some people might be wondering, why am I using just this one? Well, what of this one? Yes, don't forget, this body only accelerated like this. Here, there's no acceleration. What happened here? I will tell you. What happened here? The acceleration at this point is what they call, this one is a Jamb question. I have to tell you. The acceleration at this point, I will tell you why. Don't forget, this is constant, I told you, this is constant velocity. If you remember, this place is constant velocity. So now, because it is constant velocity, it's called zero acceleration, it's not constant acceleration. There's a constant velocity. This one is not part of this question. That's what to teach you. Since we know acceleration is v minus u over t. Now, if that body is moving at a constant velocity, who can even tell me which velocity do you think this body is moving at? Which velocity is it moving at here? Which velocity is this body moving? Yes, constant velocity. Which velocity this body is moving? Who can tell me the value of the velocity? This body is moving at a constant velocity. If you trace it to the velocity axis, you can even see it. So that body is moving at what? It's not zero. The velocity is a value. Look at it. Look at it. It's 15. It's not. This is. Oh my God. This is 5 here. Oti debi bayi. Oh, move with constant. Only you have to trace it to this axis. So what is the constant velocity that this body will be moving at? Look at it now. This velocity axis now is not this. It's not moving like this. I'm talking about this space. So the constant velocity is what? 15. It's 15. Yes. 15. So that body is moving at a constant velocity of what? 15. Now what it means is that when they say constant velocity, it means this body is starting with 15 and ending with 15. In fact, that's why it is, look at it. So if you are starting with 15 and you are ending with 15, that means your final and initial velocity is what? 15, and your final velocity is also 15 over t. In fact, the t there, who can tell me the t? The t there will now be 10 minus t there, because this is the time. It will be 10 minus 5. That will be the time. So it will be 10 minus 5. So that will be 0 over 5. So that's why this one is 0 meter per second squared. So this is what they call zero acceleration. And when does zero acceleration happen? It occurs when there is constant velocity. So that's why I used to say it. You can be reading and not reading. What do I mean? When you are reading at a constant velocity, you will not accelerate. You have zero acceleration. Do you get that? Drop it in the comment section if you get it. Do you all get that? Drop in the comment section. So you must know this thing. It's a rule of thumb. A body that moves at a constant velocity has zero acceleration. So drop it in the comment section if you get it. Yes, sir, got inside. Good. I'm only hearing 2 persons. So it's a rule of thumb. When there's constant velocity, the acceleration is 0. Okay, now let's now go to the second question. The second question is saying calculate the total distance. This one is a fact, so I have to tell you. Number 2. Total distance. Now note, total distance is the area covered by the graph. Total distance is the area covered. Please note this one, and it is measured, you must know this, it is measured in meters. It is the what? Area covered by what? By the graph. Now, it is the what? Area covered by the graph. It is the area covered by the what? By the graph. It is the area. Do you get this definition? Total distance, that's the second question. It is the area covered by the graph. Do you get that definition? Because we have to now get out. So what do I mean by area? The area of the first, this is the area. So we now split it. This is a shape. This is another shape. this is another shape. So can you see, this is a shape, this is another shape, this is another shape. So the area of the total distance will now be area of A, shape A, plus area of shape B, plus area of C. That will be the total. Please note this one. They can ask you what is the formula for the total distance. It is the area. John, do you get this? It's the total area, summation of the area. John, do you get this? Good. Now, the question now becomes, what is the area of A? Look at this A. This is shape A. It looks like a trapezium. Can you see? Check. Can you see? Am I right? Does it? Yeah, I understand. You have missed a lot. You will watch the recording. You watch the recording. Can you see that this A, who agrees with me that this A looks like a trapezium? Who agrees with me? Who agrees? If you agree, say yes. Good. You can't understand now. You missed already now. Just calm down and follow the, you will listen to the live, to the recording. It looks like a trapezium, so that means the shape A is the area of trapezium. Plus, now that's shape A, Abi. Now let's go to B. Who agrees with me that B looks like what? What does B looks like? Look at B. What does B looks like? This shape B, what does it look like? Who can tell me? This is B now. So what does it look like? Say it in the comment section. What does B looks like? Rectangle, yes. Rectangle. B looks like a rectangle. Rectangle, yes. Rectangle, good. Rectangle, yes. So we now go here. We now write plus area of a rectangle. Now that's B. Now plus the last one, C. So what does C? Look at C. What does C looks like? What does C look like? Who can tell me what does C looks like? What does C looks like? What does C? This is C. Triangle, yes. C looks like a triangle. Triangle, yes. Triangle. So we will now go here. We will now say plus area of a triangle. Yeah, let's continue. Let's go. Now this is where the work now comes in. Let's first of all start. What is the formula for area of a trapezium? Trapezium now. What's the formula? Area of a trapezium. What's the formula? It is what? Half base. Let me show you. So look at it. So this is a base. Like this is A. Some people call it A, not even base. They call it A. They call this one B, and they call this height. So it is half A plus B times times height. Half A plus B times height. That's area of a trapezium. So yeah, let's do it one by one like that. Half, let's do it one by one. Because if not, look at it. You know, this is what we decide to be trapezium. So what is this A? Who can tell me what is the length of this A? What is the length of this A? Who can tell me? If you want to look at it very well from here, can you see? So, and I twist it to this. So what is the length of this A? You know, it started from 0 to 5. So what is the length? John, what is the length? What is the length? What is the length? This is A. So what is the length? What is A? John, are you here? What is the length of this A? 5. Good. So that's 5. John, what is B? What is B? We already said this is B. So what do you think B will be? This height, this length here, what do you think it is? What is the value? If you want to check it like this, you can check it. But what is this B? What is the value? What is the value of B? What is the value of B? What is the value of B? This B, what is the value? What is the value? One person said 15, okay. What's the value of this B? The moment you just have to be tracing it. Can you see? This is the height. Once you trace it like this, you can see this is the height. This is 15. The value of B is 15. The value of B is 15. Then multiply by height. So let's go. What is the height? This is the height here. The height can, because if we trace this also, this is the height. So what do you think the height will be? What do you think the height will be? What do you think the height, this height will be? What is the value? What is the value of the height? What is the height? What is the height? John, what is the height? What is the height? If you look at it, this is the height. So what is the value? 5. Good. So times 5. So from here I can say half times, this is 20 times 5. So this is what? This is 100 divided by 2. So this 50 meter. So that's the area of the trapezium. Area of the trapezium. That's 50. So let's move to the next one, because we are doing it, which is B, shape B. Shape B is area of rectangle. That's shape B. So let's go. This is okay, let's first try it. What was the formula for area of rectangle? It is what? Length times breadth. Everybody knows that. So what is the length here? This is the length. So what is the value? If you trace this to this side, so what is the value of the length? This is the, this is the triangle. So what is this length? What is the value? You guys should, oh yeah, be fast. What's the length? What's the value of the length? What's the value of the length? This is the length we are looking for. This height. This height. What's the value? 15. Fantastic. What is the, this is the breadth, Abi? So what is the value of this breadth? What's the value of this breadth? And tell me how you got it. I want to know those that are following. This is the breadth. And this is the length. So I want to know how you got this breadth. What is the value of the breadth? What's the value of the breadth? Can you give me other 1.5 package? You oh yeah, I'm waiting. Oh, what is the breadth? What is the breadth? I'm waiting. Oh, this will be the last. What is the breadth? It's easy now. The breadth. This is the breadth. That means the breadth is 10. Fantastic. Yes. 10 minus 5. That's 5. So this thing, the length here is just 5. It's 5. That's how to get it. So the breadth there is what? Yes, 10 minus 5. Yes, that's 5. So 15 times 5 will give you what? To give you 75 meter. So let's go to the third shape, C, which is area of a triangle, which is what? Half base times height. Area of a triangle, exactly, half base times height. So let's go. The triangle, this is the triangle C. So half, where is the base? This is the base. I will know if you are following. So the base, what do you think? What's the value of base? John, you should be the first one to answer. What's the value of this base here? This 10, this 15. What's the value? What's the value of the base? Okay. Don't forget, we are talking about this triangle. This is the triangle here. We are done with. John said 10. How do you get 10? What? This is the triangle. This is a triangle. This is 10. This is 5. So how is this base 10? Oh yeah, tell me. How is the base 10? How is the base 10? I'm asking, how do you get 10? All of you that got 10, how do you get 10? How is the base 10? If this is the last part of the base 15 and this is 10, so how is this base 10? It's what we've been doing since now. If you want to get this space, it's 15 minus 10. This space is 5 now. Is that not what we've been doing since? That's what we've been doing since. Don't go and do mistake in the exam. So half, the base is 5. Oh yeah, who will be the first person to tell me what is the height? This is the height. What's the value of the height? What's the value of the height? First person to tell me. So what's the value? Don't make mistake in the exam. Yes, I understand. But you cannot afford to make mistake. So what is the height? That's why I'm doing this one by one. What is the height? What is the value of this height? What's the value of that height? You guys should be fast now. You've done like 3 shapes. So why is this different? John, what's the value of the height? Yeah, first half A plus B times I2. I don't know. So yes, 15. How do I get it? This is the height and this is the axis. So from here, I can say the height is 15. This is the height. So 15. So 15, that's half times 5 times 15 is what? 75. And 75 divided by 2 is what? 37.5 meter. So now let's add everything together. Let's add everything together because we are done with the 3. So the total distance, which is the area, the total distance, which is the area, is 50. I don't know which one you are saying. 50 plus the second one is what? 75, and the third one is 37.5. 75 plus 37.5. So what do you get? What's the total value? The total value, you get what? 162.5 meter. If I'm not mistaken, this is 125. Yes. Thank you. 162.5 meter. That means this is the total distance occupied. And I already told you to get the total distance, it is the area under the graphs. Yes, 162.5. Yeah, thank you. 162.5. We are done with that's the third. I think that's the second question also. Because this graph alone is what I will use. I upload videos on chemistry. You can check my videos. It depends. So yeah, I upload videos on chemistry. And if you want to join our WhatsApp class, you can send me a message on WhatsApp. My number is somewhere around our videos. Just send me a message to join our WhatsApp class where we take all the subject combination: physics, chemistry, biology, English. So you can join our WhatsApp class. You can send a message to me on WhatsApp. You will see my number in my description. Send a message to my WhatsApp. So that's it. Now the last one is, the third one is retardation. Retardation. That's the third one. And I told you that retardation also means what? No. For people starting from no. Retardation means deceleration. Retardation means acceleration. Now don't forget, look at it. From here, this guy is decelerating. You know, this guy, look at it. The guy moved from here, from initial 5 meters per second up to this 15. Then it moves with a constant velocity. Then from here, it's decelerated. Now, this thing might be a bit tricky if you don't pay attention, because you have to pay attention. That's why this will be the last thing, so that you can either rewatch it or you can, digest it. Now, look at it. This guy is decelerating from here, like this. From here, like this. That means the initial, because it's decelerating, that means there's an initial velocity here. Abi, there's an what? Initial velocity, right? That means the initial velocity will be the final velocity that this guy took. Like the v here will be the final velocity, yes, which will be the initial velocity of this body that is decelerating, because that's where it's starting from. So the body is starting from it. That means the u here will be 15 meters per second. It will be what? Look at it very well. Can you see this body was moving? It got here. Can you see? Then it now moved at a constant velocity 15 up to this point. Then the body now start decelerating and have a final velocity here. So that means the body will have an initial velocity u, which is what? 15. In fact, this is very, very important. U will be what? 15 meters per second. Now, because the body will decelerate, it will start coming down and have a final velocity, because the final velocity at this point will be 0. V will be 0. But what is the time? The time here will be, this is the axis of, this is where it starts to decelerate. So you trace it down, then like this. What will be the time? What will be the time that is going to use? I want to see smart people. What will be the time that this body will use? Who can tell me the time? What will be the time? Who can tell me the time now? This is 15, this is 10, and this is the body that decelerated. So what is the time? The time is 5. Because the body started here. Good. Yes. No, it's not 10 minus 5, it's 5. 15 minus 10. That's how we got 5. So that's the time. 5 seconds. Don't forget, our acceleration is equals to v minus u over t. What is v? From here, we got v to be 0. What is u? We got u to be what? 15. Then we got our time to be 5. Now this even shows something. Minus 15 over 3 over 5. Sorry. Then this is what? Minus 3 meters per second square. In fact, this minus shows what? Deceleration. The minus shows deceleration. The minus shows deceleration. So this is the answer to it. So negative of acceleration is deceleration. Do we all get it? If you want to join our WhatsApp class, you can send me a message on my WhatsApp. Our number is on the description. Send me a message. My number is on the description. Send me a message to join the WhatsApp class. So can you see that? Do you get it? Do you get it? From here, then we use the formula A is v minus u over t. Then good. The last one is we are asked to calculate average speed. Average speed. This will be the last thing we'll do. Now, average speed is total distance. Please take note of this. Over total time taken. Total distance over total time taken. Now, don't forget, we've actually calculated total distance. What do you think the total? Who can tell what is the total distance? Who can tell what total distance is? If you have been following, what is total distance? This will be the last part we do today. What's total distance? What is the total distance? So, okay, the total distance is what? 162.5. We already calculated it. 162.5. What is the total time? Because we need total time. You come here from the graph, you can get the total time. What's the total time? The body started from here and moved to this place. So the total time that the body used is what? What's the total time like that? What's the total time? Oh yeah, what's the total time? What's the total time? 30 seconds. 15. Good. Fantastic guy. I know what you did. You added 5 plus 10 plus 15. No. The total, this is the total distance. The body move from 0 and cover 15. So the total distance is 15. Is 15 divided by 15. So 162 divided by 15 is what? I think that should be around maybe 10 point something, 10.8 something. Yes, Dolua Toyin, yes. So what's the value? I think it should be 10 point something. I can't 10 point what? 8 what? I think it's 10.8 something. Maybe 82 or 83. You can check that. It should be 83. 83 meter per second. So that is the average speed. That's the average speed. 10.83, good. Yes, that's the average speed. So this is where we will end the discussion. This will end the discussion. So I hope you've gained something. If you have not followed me, do that right away. If you have not followed me, do that right away. Subscribe to my channel. So yeah, and if you want to join our WhatsApp class, sorry. Can you hear me now? I said this is my WhatsApp line. If you want to join our WhatsApp class, send a message to me on WhatsApp. You understand? This is my WhatsApp line. Send a message to me on WhatsApp. Tell me you're from TikTok, that you want to join our WhatsApp class. So you'll be taught all your combination, your maths, your physics, your chemistry, your biology, your English. Understand? So thank you so much. It's good to be here. Maybe you want to see my face. Let me show you my face. This is me. My pen has finished. So yeah, if you want to join our WhatsApp class, send me a message. This is my face, in case you have not seen me. See, my pen has finished because of you. Subscribe now. Yeah, no problem. I will reply after this call. Subscribe now and share to your friends. Share to your friends. Share to your friends. Go and watch all my videos. Comment. I will know if you comment though. I will know. So see you guys tomorrow. And go and follow me on TikTok. Go and follow. This is my TikTok account. Yeah, thank you. This is my TikTok account. The chemistry tutor on TikTok, Facebook, and Instagram. Go and follow me there right now. Have you guys subscribed to this channel? So this is my username. Have you guys subscribed? So if you have not subscribed, do so now. If you have not subscribed, do so now. So see you guys when I see you. Bye for now. I don't know what to talk.